before we start talking about functions, we need to come up with some common definitions. So I'm going to start with down the list a little bit with the word relation. Now, a relation, like a relationship, is basically an interaction between two things. A mathematical relation is a rule describing the correspondence between two values. So it's how one value affects another value. The two things that make up the inputs and outputs of a relation are the domain and the range. The domain is basically the set of all possible inputs, or the values that I'm going to put into a relation, and the range is the set of all possible outputs, so what I get out for that. So what a relation does is it assigns a value in the range to each value in the domain. Okay. Now, another way of thinking about the domain, or another word that represents the same idea, is input or independent variable. Similarly, the word range is used interchangeably with the word output or dependent variable. So a relation takes some input and gives me some other output. And we can represent that in a number of different ways. We can represent a relation by a sentence or rule describing exactly what's happening. We could represent a relation numerically by a table of values or a set of points. We could represent it by an equation telling me how the output value is calculated for each given input value. Or we could represent it by a graph describing how the dependent variable reacts to values of the independent variable. First, let's consider how to represent a relation numerically. Well, we can represent a relation numerically actually in a variety of different ways within itself. The first way we're going to look at is called a map. Now, the word map may bring to mind imagery of a treasure map, and they actually work in much the same way. If you think about what a treasure map does, is it's just a visual representation for the reader describing how to get from some starting point to some ending point, which is where your buried treasure is. In a mathematical map, it tells you for each value of the input exactly how to get to the value of the output. So here we can see a visual representation of the inputs and a visual representation of the outputs. So what this relation does is it starts at 0 and takes 0 and sends it along to -2, and it also sends 0 along to 1. From 1, it sends it along to 2. For 2, it sends it to 1, and for 3, it sends it to 4. So it's just a visual way of telling you when you plug in 0, you'll get out -2 and 1. Another way we can represent that same idea is with a table or chart. So a table is taking a value of the domain and telling me what value of the range it is assigning to that value of the domain. Now, these two representations are representing the exact same relation. Notice that the relation sends 0 to both -2 and 1, which is exactly how it's being described here in this table. 1 gets sent to 2, 2 gets sent to 1, and 3 gets sent to 4. So that's the exact same relation as we see here in the map. Yet a third way of representing a relation numerically is by a set of points. Now, typically, we represent a value of the domain by a variable of x, and a value of the range by a variable of y. So when I have a set of points x comma y, I can note what each of the outputs are going to be for that given input. So again, notice that the value 0 in the domain gets two values of the range. So I have 2 points for 0, the one that gives it -2 and the one that gives it 1. For 1, I have only 1 point. It sends me to 2, 2 to 1, and so on. Now, a special kind of relation that we're going to focus on is actually a function. Now, what makes a function different is that it's a relation that assigns it only one output. So if it's a function, it has only one output for each given input. Notice that my relation depicted above is not a function because for the value 0, I get two different outputs. So this relation is not a function. So what does it exactly mean to be a function? Well, consider the following example.
Consider the function a snack machine performs. It accepts an input in the form of money, performs a function, and gives me an output, in this case, a delicious oatmeal square.
For my input of $1, I got exactly one snack output. I'd say the machine is functioning properly.
However, if I was to insert my dollar, the machine performs its function, and I get two outputs. Wait a minute, is that bumblebee tuna?
In this case, it didn't function. It gave me two different outputs.
I inserted a dollar and asked for an oatmeal square, and I got an oatmeal square and a can of bumblebee tuna. That's not what I asked for. It's not functioning properly.
And I'm a little concerned as to who's sticking tuna in a vending machine. So let's look at another example. Again, to remind us that a function is just a relation that for each input gets exactly one output. So just to note, if an input has more than one output assigned to it, it's not a function. So let's check our first one. Well, taking a look at elements of the domain, 5 gets assigned exactly one output of the range, 7 gets assigned exactly one output, 8 gets assigned exactly one output, and 10 gets assigned exactly one output. So I would say that this is functioning properly. So yes, this is a function. So I'm looking for ones that are not a function. So that is a function. Now, don't be confused because it is okay for two different values of the domain to get the same output. What we cannot have happen for a function is that one input gives me two different outputs. So it's okay for two inputs to give the same output, but you can't have one input give you two outputs. So an example of one input giving you two outputs is number C, or letter C. The input of 1 gives me two different values when I get the output. So this is not a function. Thinking of it as a map, what this relation actually does is it takes the values 1 and 0 and assigns it to either -7, 5, or 9. The reason it's not a function is that 0 gets sent to 5, that's all well and good, but 1 gets sent to both -7 and to 9. So that's not okay. You can't have one input being assigned more than one output. Just to double check to see if that's the only one that's not a function, for my given values of the independent variable, I have different values here. For y, I have 0, -4, 3, and 0. Here, again, I have that same problem. 2 is being assigned two different outputs. That's no good. So b is not a function either. In part D, so actually let's label that not a function. In part D, for each of my values of the independent variable, so each value in my domain gets assigned a different output. None of these outputs are the same. So since each value of the domain gets assigned a different value of the range, that's okay. This is a function. Yes, it is a function. We'll explore the relationships between functions, relations, domain, and range a little bit further when we come into class next time, and I will see you then.